In the present video, we're going to continue talking about algebra with Maxima, and we're going to talk about radicals. Basically, this means square roots, because higher order radicals are more complex, and so there's plenty of interesting stuff about square roots that we're going to do. We're going to start with those. And so we have radical and root. SQRT is the function that does square roots in Maxima, and you have if it is in a perfect square like 25, your result will be a single integer number, and so this is a rational result. If you cannot get a result, you get a rational number like this. Here we have a couple of irrational quantities. Now, when you have, for example, a square root of 3, square root of 3, square root of 3 multiplying here, you have similar radicals, and you can combine them in summations and subtractions and so on. This will be non-similar radicals, which will be easy to reduce. Reducing a radical means simply simplifying the radical. And so if you have something like the square root of 9a cubed, will be simplified to simply 3a square root of a. Let's check that. Let's do square root of 9 times a cubed. It should be equivalent to this, but in both cases you get Maxima to give you a fractional exponent. That's just the way the Maxima works. Even if we use the radcan, which is the simplification of radicals, you get the same result. Let's try some other examples here. Whenever it's possible, you do get square roots, but if it is a complicated combination like this, then you're going to get the fractional exponents. This symbol here is the absolute value of x, and that's because the square root of x squared in general is equal to the absolute value of x. So let's look at this first case. Square root of 6 over 3. Square root of 2/3. Square root of 6 over 3. If you were given something like square root of 2/3, but I think the Maxima it will keep that value. Even if you use radcan, which is the rationalization, it doesn't do it. You have to carry that out by hand, actually. For cubic roots, use raised to the 1/3. This can be rationalized this way, but it has to be done by hand. 25 to the 1/3. With radcan, give you 5 to the 2/3, which is the same as doing this. When the factors in the subradical quantity are common divisors, like 16 to the 1/8, simplify to the square root of 2. This, you get that, and so on. 3a square root of 2a squared. I try to simplify quantities within radicals. If I try to rationalize, I don't get Maxima. What happened in here is that in the olden days, we tried to rationalize denominators to be able to manipulate it. But in a software like Maxima, that is no longer a problem. Even if you have radicals in the denominator, when you're combining an operation, they will be taken care of by the software. Here you have some examples. We have cubic roots and square roots and 6 roots, and the least common multiple of that is 6. And so if we raise everything to the, or try to find the 1/6 power, Maxima will simply give you the same results as before. Maxima simplifies that always. There's no easy way to keep those results in 1/6, so we can combine them. But if you add those terms, then it will figure it out on their own. Reduction of similar radicals, this is like square root of 5 is the common factor, square root of 3 in this case. And so we end up with results like these and these. This one will, you need to use expand to get the final result. We'll see some example with radicals here. Using radcan to simplify things. Factor to factor things out. Radcan to simplify things. Multiplying with radcan. Another multiplication here. Multiplying and simplifying with radcan. Multiplying compound radicals, it gives you this complex result right there. There's another one. Anyway, the idea is here that you can work out your radicals and let Maxima take care of the final results. Here are division of radicals. Radcan simplifies it a little bit. So if you want to try to simplify it, use radcan. You may end up with results like this, but radcan cannot do more. Powers of radicals. Products. Look at the last product right there. Radicals of radicals. This is square root raised to the 1/4. Square root to the 1/3. Square root to the 1/3. Rationalizing the denominator of a fraction. What you want to do is split the fraction into its numerator and denominator, then multiply by the denominator, everything by the denominator, and then reconstruct the fraction. And so here are the steps. Here's the fraction, his numerator, his denominator. The new numerator is the original numerator multiplied by the denominator. The new denominator is the original denominator multiplied by itself, which is the denominator square. Then put this over this, and it simplifies a little bit. But the fraction has been removed from the denominator. So we're not helpless. We can follow this procedure to eliminate radicals from the denominator. So these are the rules. Basically, for the two examples presented earlier on, those are the rules. I'm going to do it here again. If the root is not a square root,